The following is an example of triangulating coordinates. We're going to start off with some dimensions that were measured in the field, show how if we apply those dimensions we won't get an actual rectangle, and then show how we'd actually do that properly. So the first dimension is along the far wall, and that's 2,700 inches. And we can actually select the line, type that value in exactly. So we'll put in 2,700 inches, return. And now if we put a dimension on that, we have exactly that length. The bottom side, from the measurements we took in the field, is 1980, and we can go ahead and put in those exact dimensions. So we'll put in 1980 inches. Okay, and again we can drop a dimension on that, and so that's exactly what the dimension was. The top line is not quite square. It actually turns out to be 1985 inches. Again, dropping a dimension on that. And that leaves the far wall, which we actually measured to be 2,468 inches. But if we actually connect the line between those 2 points and drop a dimension on it, we'll see that it's 2,700 inches. And so the reality is that it's not quite square. If we grab the points and try and move things in so that everything matches up with our dimensions, we can kind of maybe get something, but we wouldn't be accurate regardless. Now, a better way of doing this, and we'll go ahead and delete this and start over again, is we'll start from the far wall, and we'll put in our 2,700 inches. Now, rather than actually just go with a single dimension here, what we'll do is we'll actually measure this length from both points, and we'll triangulate using arcs. And so the first dimension, just going along the base, is 1,980 inches, and we'll put that in. And now when you drop a circle on the drawing and move it into position, we know that all the points along this radius is going to be 1,980 inches. Now, rather than just measure the top, what we're going to do is we're going to measure from this other point to this far corner and use that dimension. So what we'll do is we'll clear this line, all right, and now we'll put in the actual measurement, which was 3,260 inches. And now if we drop that radius in, or that circle in, we now know the exact location of this point is going to be measuring from this side. We'll just actually put an arc dimension on this so you can see it. 1,260 inches. This one is 1980 inches. And by selecting both of those, we can calculate a point exactly where it needs to be. So rather than being 90 degrees, which we thought, that angle is actually going to be, hold on a sec, 87 degrees. Go ahead and get rid of these two arcs, although we've got our line in there. And in a similar fashion, we can measure the top distance, which, as we recall, was 1985 inches. And drop that arc in. And now the second distance was measuring down to, from this corner up to this corner, was 3,250 inches. And drop that arc in, put it in its location. And now by selecting both of those arcs and creating a point, we now have, go ahead and grab this, oops, wrong point. We drop our dimension on there, auto. We have our 1985, and now if we created a line between these 2 points, we would have the dimension we measured in the field, which was 2,468. So we've got the exact configuration that's actually represents a roof. And we'll see that, get rid of some of these other extra dimensions, that for angle dimensions, nothing's exactly square. And that's my presentation. Thanks. And that's triangulation, and that's how you can do that. It's a little bit crude for in the field, but something that we'll work on to make better. Thank you very much.